Myself M. Dinesh Kumar, Assistant Professor, Department of Mechanical Engineering, Konganadu College of Engineering and Technology, Trichy, Engineering Thermodynamics, Unit 2, Second Law and Entropy Principles. These are the syllabus. Kelvin Planck and Clausius statement, heat engine and heat pump, reversibility, Carnot cycle, Carnot theorem, performance, Clausius theorem, concept of entropy and TS diagram, entropy change for pure substance. Limitation of first law. First law of thermodynamics, law of conservation of energy, states that energy cannot be created or destroyed. In first law of thermodynamics, heat and work are mutually interconvertible. That is a limitations in first law. There is no specification of the direction of flow of heat and work. So the hot body to cold body or cold body to hot body, heat is flow or not, which is not clearly mentioned. For example, take a coffee at a temperature 70 degrees Celsius to the surrounding of the system. Heat flow from one place to another place. It is not mentioned. Either it may be hot body to cold body or cold body to hot body. But practically the heat will be transferred from hot body, the coffee 70 degrees Celsius, to the surrounding temperature is a cold body. It will be flows. So it's not clearly mentioned in first law of thermodynamics. Then second limitation, both heat and work are mutually interconvertible. It is impossible to construct like that system because heat cannot be fully converted into mechanical work due to the various reasons. It may be the friction, like that. Kelvin Planck statement. To overcome the limitations of first law of thermodynamics, the second law of thermodynamics will be introduced. In that case, the two statements are declared. First one, Kelvin Planck statement. Second one, Clausius statement. In Kelvin Planck statement, it is impossible to construct an engine working on a cyclic process which converts the entire heat energy supplied into equal amount of useful work. So as per the statement of first law, heat energy given to the system, that is the heat engine, it will be converted into full of work. That means heat supplied is 100 kilojoules, means work done is also 100 kilojoules as per the first law of thermodynamics. It is impossible to construct. So some losses is there. The heat supplied is, for example, in this diagram, heat supplied is 100 kilojoules to the heat engine. It gives some work output as a 40 kilojoules. So the remaining is heat rejected, so 60 kilojoules to the sink. This is possible. This states the Kelvin Planck statement. Next one, Clausius statement. It states that heat cannot flow from cold reservoir to hot reservoir without any external aid. From this diagram, this is the cold sink. So heat will transfer from cold sink to hot sink. That is the heat source. It is impossible without any external devices. It is possible when the external device is used, heat pump or refrigerator, like that. Okay. So in this figure 2, heat sink is a heat extracted 60 kilojoules, which is to supply to the heat pump. Heat pump having some work input, then it will be processed, then 100 kilojoules of heat output will be delivered to the source. So the heat pump is a device which is used to maintain the higher temperature than the surrounding. Similarly, that device, it may be a refrigerator, means maintain the temperature lower than the surrounding. So that is the difference between the heat pump and a refrigerator. It's also stated in the Clausius statement. Perpetual motion machine 2, PMM2. If the engine exchange the heat only in single thermal reservoir in which heat supplied is completely converted into equivalent amount of work, its efficiency becomes 100%, which is impossible. That kind of machine we call it as perpetual motion machine 2. Reversible process and irreversibility. A reversible process is one that can be executed in the reversible direction with no net change in system or surrounding. At the end of forward or backward process, reversible process, both systems and surroundings are returned into the initial states. Practically, there is no process are reversible. However, reversible processes are theoretically most efficient process. All the real processes are irreversible due to irreversibilities. The various reasons for irreversibility. First reason is friction. Second one, sudden expansion and compression. Then heat transfer between the bodies with a finite temperature difference. These are all the reasons for irreversibility. Practically all the processes are irreversible process. Next one, Carnot theorem. Carnot theorem states that no heat engine operating in a cyclic process between two fixed temperatures can be more efficient than reversible engine which is operating between same temperature limits. Carnot cycle's efficiency gives the maximum efficiency. The Carnot cycle and the Carnot engine we discussed here. A Carnot cycle is a hypothetical cycle consists of the four processes. First one, two reversible isothermal process, two reversible adiabatic process. In isothermal process, heat addition and heat rejection will be takes place. In adiabatic process, compression and expansion will be takes place. Assumptions made in Carnot cycle. Piston moving in the cylinder does not produce any friction, but practically all the engines having friction. Second point, the cylinder head is arranged in such a way that can be perfect heat conductor or heat insulator. But in this case, there is no heat loss occurs in the system. Third point, the wall of the cylinder and piston are considered as perfect insulator of heat. Again the same point. Then heat transfer does not affect temperature source or sink. Reservoir, it does not affect the temperature limits. The higher temperature and lower temperature which not affects the heat transfer rate. Fifth point, compression and expansion processes are reversible, but practically all the processes are irreversible process. Working is a perfect gas has a constant specific heat. Working medium of this Carnot cycle is perfect gas. Air is a considered as a perfect gas in this cycle. Carnot cycle, it is also called as constant temperature cycle. It is introduced by Sadi-Carnot. Already we discussed the four processes. Process 1 to 2 isentropic compression, 2 to 3 isothermal heat addition, 3 to 4 isentropic expansion, 4 to 1 isothermal heat rejection. Already said the area under the curve in PV diagram we call it as work done. Similarly, in the TS diagram, temperature entropy diagram, area under the TS diagram we call it as the heat transfer. We can derive the results. The efficiency of Carnot cycle is equal to T1 minus T2 divided by T1, that is heat supplied minus heat rejected divided by heat supplied. The Carnot cycle's efficiency gives the maximum efficiency rather than the other engine. Concept of entropy. Entropy is an index of unavailability or degradation of energy. By using this formula, change in entropy, change of heat transfer divided by absolute temperature, dQ divided by T. Here the same statement is mentioned. Del S is a change in entropy of the system. Change in heat from the system is a Q. T is the absolute temperature of the system. Then TS diagram, this change of state from 1 to 2, some change of entropy may occurs. This is the occurs by this change of temperature from state 1 to 2. There is a absolute temperature. This is unavailable energy. Thank you.